So we've got a binary number here, and we want to convert it to decimal. Why do we want to go to decimal? Well, because that's the number system that we all kind of grew up using, right? It's the most commonly used number system. That said, it's not the only number system. Of course, we have binary, and we'll explore a couple other ones later. But there's also some kind of more dead number systems, like I think mine's used base 25, which is kind of interesting. Don't quote me on that, but I know it was some crazy base. Interestingly, because of the base system that the Mayans used, that's why they predicted the Earth was going to end in what, like 2012 or something like that. And all it was is because they were counting up numbers, and they essentially got to 999 years, and they just didn't want to make their calendar go up to 1,000, and so they said that's where we're going to stop. So that's why that's kind of where that came from. Kind of interesting aside. Anyway, so what we're trying to do is analyze this 5-bit number here, right? This is 5 digits, or in binary we call them bits. So where do we start? Well, what I like to do is start with the least significant bit. So least significant means that bit has the smallest value. And just like our regular number system, decimal, the smallest digit, or the rightmost digit is always our least valued digit. So like normal in decimal, this would be our ones place, and in binary it's also our ones place. So I'm going to label this LSB, least significant bit, and that must mean that this is our most significant bit. So there we go. Now we can kind of get started here. Now we know that we want to start on our least significant bit. So the value of this place right here is our base, which is 2, to the power of 0. Remember, we always start at 0 because this is our ones place. So we've got 2 to the power of 0, which is 1. And we're going to multiply it by our digit value, which in this case is sideways 1. There we go, a little bit straighter. Now let's look at this one here. We've got 1 times 2 to the power 1. So we've got a nice progression here. We just go 2 to the power 0, 2 to the power 1, and so you should guess that this is 0 times 2 to the power 2. And then we've got 0 times 2 to the power 3. And last but not least, we've got 1 times 2 to the power 4. And I realize that these operations with a 0, they're not going to add any value, but just for completeness, I like to show them. When you're doing your work for assignments or homework, if you decide not to include that zeros in there, it's not that big of a deal. So to get this decimal value, right, we need to actually add all of these products together. So let's bring that down an intermediate step here. So this is 1 times 16, and then 2 to the power 3. So this is 0 times 8. This is 0 times 4. This is 1 times 2. And last but, well, I was going to say last but not least, but actually it is the least, because the least significant bit. But so last we have 1 times 1. And then to bring this down another step, right, we're going to go, and I'm just going to carry out the multiplication, and this time I'm not going to include my 0 values here. So that leaves us with 16 plus 2 plus 1. So we've got 16, 17, 18, 19. And kind of a handy little notation that I like to do, especially when you're doing stuff with number systems, is to write what the base of that number is as kind of a little subscript here. So I'm going to say that this is now in base 10. So that would mean here I'd put base 2, right? This is a base 2 number, this is a base 10 number. Just kind of something handy to keep track of things.